Okay, Assalamualaikum class. This is the last topic that we have in the last chapter. So we have here is volume by cylindrical shell method. Okay. So this is the third method that we use to find the volume. Alright, in this section, okay, we will discuss about another method for finding volumes, that is by taking the approximating strip. Alright, this is the keywords. Taking the approximating strip parallel to the axis of rotation. Parallel to the axis of rotation, meaning we will assume that you want to cut a strip from the shaded region that is parallel to the axis of rotation. So instead of perpendicular to the axis as in the disc and washer methods, meaning the concept will be quite different with your disc and washer method. So this method is called as the cylindrical shell method. Alright. Okay, in this method, the differential are strip HDX or HDY is revolved about an axis of symmetry parallel to the strip. Okay, so the strip is the most important thing in your cylindrical shell method. Alright, the strip is revolved about the rotation line. Okay, next, what is the formula? The formula of volume by cylindrical shell method is given by, okay, this one. V is 2 pi the integrations from a to b radius times height dx or dy. It depends on your diagram. Alright. Okay, now let's look at the diagram. Okay, for the first case, let's say we have two curves. Okay, y equals to fx and y equals to gx, and the rotation line is on the y-axis or parallel to y-axis. Okay, so now let's see. Okay, your rotation line is x equals to 0. Okay, for cylindrical shell method, the first step for cylindrical shell method, the first step is you have to assume that you want to cut a strip parallel to your rotation axis. So this is your strip. Okay, this is your strip. The red one is your strip. Okay, next. Okay, so the strip is your height in your formula. Continue next. So what about the radius? So the radius will be the distance between the strip and the rotational line. Okay, so the formula is given by 2 pi the integrations from a to b. Okay, so this is your a, right? This is your a and this is your b. From a to b, radius times height. Radius times height, dx or dy. Okay, so later on we will see the example for dy. Right, the height will be either top minus bottom and right or right minus left. Okay, so here your height will be top minus bottom or right minus left. It's not the radius anymore. Okay, alright, and your radius is the distance between the strip, okay, and the rotation line. So look at the distance. Alright, okay, now let's look at for the second case where your height is right minus left. Okay, now we have for second case is for the case where the height of your strip is right minus left. Okay, look at here, we have a curve x equals to fy. Okay, and the rotation line is on the x-axis. Okay, when you cut your strip will be parallel to your x-axis, right? And the height will be right minus left. Okay, and your radius will be the distance between the strip and the rotation line.